Alright, so here is a video for the review sheet for the Chapter 4 test. Using the rational root theorem, which would not, that's the key word here, you got to really pay attention to these two questions, be a possible zero. So when we look for possible zeros, we look for factors of 20, which was 1, 2, 4, 5, 10, and 20. And then the factors of the 4, 1, 2, and 4. So we can have any combination of these numerators over these denominators. So first of all, is 3 in that list? 3 is not on that list because you can't divide 20 by 3. So 3 is definitely not a possible factor. Is 4 a possible factor? Yes, it's right here on my list. And is 3/4, that's not going to be a possible factor because 3 is not a factor of 20. And then 5 is also on my list, so 5 is a possible factor. So the ones that are not are A and C. Now when you look at question number 2, which would be a possible zero, so now we're looking for ones that are possible zeros. So we have 15, 1, 3, 5, 15, and 6 is 1, 2, 3, and 6. So any combinations of these, again, numerators over these denominators. So 3 is on that list, that's a possible zero. 4 is not on that list. If I look at 5 over 6, so 5/6 would be on that list, and so would 5. So my answers are C, A, C, and D. So that's how you want to look at those problems, but you really, really need to pay attention to what it's asking. Okay, one question is going to ask which ones are not, and another question is going to ask which ones are. So this one says identify the number of solutions or zeros. For that one, you look for your highest exponent. Your highest exponent here is 4, and so the possible number of solutions, not possible, but the number of solutions will be 4. Remember, that could be too imaginary, too real. They could be irrational, but there will be 4, and it could include double roots. The next set of questions is factoring completely. So we need to really pay attention to whether we have a sum and difference of cubes and sum and difference of squares. So we're looking for cubes, squares, grouping. So we're going to look at those things and possibly a polynomial in quadratic form. So n cubed plus 100, or I'm sorry, 1,000. 1,000 is a cube, n cubed is a cube, so this is a sum of cubes. So this formula is a plus b, a squared minus ab plus b squared. And remember, when it's a difference, it's a minus b, a squared plus, it's not looking at right, plus ab plus b squared. So a in this case is what cubed is n cubed, and that's just n. And b is what cubed is 1,000, that's 10. So my n plus 10, n squared, that's a squared, minus a times b, 10 times n is 10n, plus b squared, which is 10 squared, plus 100. This is completely factored. Okay, you cannot factor this trinomial anymore, so you're done. Number 5, we're going to look for, we have 3 terms, so, and they all have an r in common. So first we're going to factor out an r. We get r squared plus 12r plus 32. Now I'm just looking at a factoring minute problem. What two numbers multiply to 32 and add to 12? That's 8 and 4. So r times r plus 8 and r plus 4. And that's your factored completely. Looking at number 6, again, 125 is a perfect cube, so that means B is 5, and W is your A. This is a difference because it's subtraction, so it's W minus 5, W squared, A squared, plus, remember it's the same sign, it's the opposite sign, then it's always positive. So 5W, that's your A times B, and 5 squared is 25, so plus 25. And that's not factorable. You can't find two numbers that multiply to 5 or 25 and add to 5, so it's not factorable. Number 7, I'm going to write again down here, make some more room. This is n cubed plus 10n squared plus 7n plus 70. When we have 4 terms, we're looking at factoring by grouping, so I'm going to group together n cubed plus 10n squared. And I'm going to group together 7n plus 70. Factor out n squared times n plus 10. And I'll factor out a 7 out of the second parentheses. N plus 10 again. Now I'm going to factor out my n plus 10. So I get n plus 10 times n squared plus 7. And that's my final factorization. Number 8, 3a cubed plus 6a squared plus 7a plus 14. Again, I have those 4 terms. I'm going to try to factor by grouping. So 3a squared I'm going to take out, and I get a plus 2. And 7 times a plus 2. And then we're going to factor out the a plus 2. So I get a plus 2 and 3a squared plus 7. And number 9, 16n to the 5th minus 625n. Here you're looking at perfect squares. 16 is a perfect square and 625 is a perfect square, so we'll factor out an n first. We get 16n to the 4th minus 625. And this is 4n squared plus 25 and 4n squared minus 25. And now I still have perfect squares, so I can factor it more. I can do n. We said that when it's plus, it factors into imaginary factors. 2n plus 5i and 2n minus 5i. And then the 4n squared minus 25 factors to just 2n plus 5. And let's see if I can fit it on here. 2n minus 5. That's your complete factorization there. Move some of this up. This is the last problem. So 10 is 27, which is a perfect square. Perfect cube. And 125 is a perfect cube. So now we have a difference of cubes. In this case, my A is 3w, and my B is 5v. So I'm going to go back to my sum and difference pattern. A minus B, 3w minus 5v. A squared, that's 3w squared. It's important to put the parentheses because the 3 is going to need getting squared, plus, because this sign's opposite of what's in the original problem, 3w times 5v, and then plus, in parentheses, 5v squared. So when I simplify, 3w minus 5v is 9w squared plus 15wv plus 25v squared. And that's 1 through 10. Okay, so find all real solutions of the equation. We're going to try to factor. If we can't factor, then we'll use our P's and Q's. So looking at number 11, x cubed minus 8x squared plus 11x plus 20. So when I look at this, I see a common factor of x squared, but I don't have a common factor on the 11x and the 20. So that's going to tell me that factoring by grouping is not going to work. So I'm going to use my p's and q's. Factors of 20 are 1, 2, 4, 5, 10, and 20. I can look at my Descartes' rule of sign, and I have one sign change, two sign changes. So I have a yes, a no, so that's 2 positive, and that means at most there could be 1 negative. There might be no negatives, but we're going to start checking positives with this information. Now remember, these are all plus or minus. So I'm going to check 1, and I get 1, negative 8, 11, and 20. 1, 1, negative 7, 4, 4, not 0. 2, 1, negative 8, 11, 20. 1, 2, negative 6, negative 12, negative 1, negative 2, not 0. Let's try 4. 1, negative 8, 11, and 20. 1, 4, negative 4, negative 16, negative 5, negative 20, 0. So that's a 0. So one of my x's equals 4. Now remember, when I'm down to 3 numbers, that's a quadratic. X squared minus 4x minus 5. And what 2 numbers multiply to negative 5 and add to negative 4? X minus 5 and x plus 1. That means x is equal to 5 and negative 1. There's no need to keep checking the list once you have 3 numbers. So we have solutions of 4, negative 1, and 5. Let's look at number 12. Okay, number 12. S to the 4th. Now I want to move the negative 24s squared over. So minus 24s squared. I want to put them in order from highest exponent to lowest exponent. Plus 128 equals 0. Now this is a polynomial in quadratic form. It looks a lot like our factoring minutes. It just has an s to the 4th instead of an s squared. So what 2 numbers multiply to 128 and add to 24? So let's think about that for a minute. 128 is 64 times 2. So 64 times 2. 64 is 8 times 8. So this could be 8 times 16, because that would be 16. And 8 plus 16 is 24. So this is going to work. We got s squared minus 8 and s squared minus 16. S squared minus 8 doesn't factor anymore because 8 is not a perfect square, but s squared minus 4 does. It's s plus 4, s minus 4. And it has an equal sign. It says find the real solution, so I'm solving it. So we have to solve s squared minus 8 equals 0. So s squared equals 8, and s equals plus or minus the square root of 8. Don't forget your plus or minus. And then we have negative 4 and positive 4. And those are our 4 solutions. Let's move this over and up. Let's look at number 13. 6x cubed minus 7x squared minus 29x minus 12 equals 0. Again, we don't have any common factors here. We only have the x squared in common here. So we're probably going to end up using our p's and q's. So my list of p's are 1, 2, 3, 4, 6, and 12. Those are my factors of 12. My factors of 6 are 1, 2, 3, and 6. Let's look for sign changes. We have 1 sign change, 2 sign, no sign change, no sign change. So positive would be 1. And then if I put in f of negative x, that becomes negative 6x cubed minus 7x squared plus 29x minus 12. So that's no sign change, yes a sign change, yes a sign change. So there's 2 negatives. Okay, I checked that just to see maybe there might be 0 negatives, and then I would not check my negatives. Now my p over q's, I'll start with the plus or minus the whole numbers, because that usually will get me the answer before. So we're going to start with, let's try negative 1. 6, negative 7, negative 29, and negative 12. And I get 6, negative 6, negative 13, positive 13, negative 16, positive 16, and not 0. So let's just try positive 1 just in case that's my answer. 6, negative 7, negative 29, and negative 12. So that's 6, 6, negative 1, negative 1, negative 30, 30, and okay, that doesn't work either. Let's try negative 2, 6, negative 7, negative 29, and negative 12. 6, negative 12, negative 19. Positive 38, and 9. And that's negative 18, which is not 0. Okay, I know it says there's 2 negatives, but I kind of feel like I should check these small ones too. So 6, 12, positive 5, 10, negative 19, and not negative 19, negative 9. But that's still not going to get me. No, it is negative 19. Negative 38, not 0. And try 3, 6, negative 7, negative 29, and negative 12. 6, 18, 11, 33, 4, 12, 0. Oh, there we go. We found one. So x is equal to 3, and we have 6x squared plus 11x plus 4. So let's see if we can factor that. Make a little bit more room for myself here. And that's going to be 6x and x. Let's try 4 and 1. That gives me 24x and 1x. That's not going to work. Let's try 2 and 2. That's 12. 12x and 2x. That's not going to give me 11. And if I put 4 and 1, that's going to give me 10. So the 6x doesn't work. But let's try 3x and 2x. How about 4 and 1? That's 3x and 8x, which could be positive 11 if they're both positive. So we get 3x plus 4 equals 0 and 2x plus 1 equals 0. Subtract your 4. 3x equals negative 4. X is negative 4/3 minus 1. 2x equals negative 1. And x is negative 1/2. And then what was the other one we found? X is equal to 3. So these are our 3 solutions. And let's see. write the polynomial function of least degree that has the leading coefficient of 1 and the given zeros. So we did this on Friday. If my 0 is -2, my factor is x plus 2. If my 0 is 3, my factor is x minus 3. If my 0 was 8, my factor is x minus 8. And now I just multiply it out. We have a leading coefficient of 1, and none of these are squared. That's what least degree means. None of them are like double or triple roots. So we have x plus 2 times x minus 3. I'm going to multiply these two together first. I get x squared plus 2x minus 3x minus 6. That's x squared minus x minus 6, and I'm going to multiply by x minus 8. So this is plus 48, positive 8x. Let's move this over, give us some space. And negative 8x squared. And then negative 6x, negative x squared, and x cubed. Then we have x cubed minus 9x squared plus 2x plus 48. And that's the answer for number 14. Number 15, we have a factor of 0, that means x, or a 0 of 0, that means our factor is x. A factor of 5 is x minus 5, and then the factor of 7 minus square root 5 becomes x minus 7 minus square root 5, and x minus 7 plus square root 5. Double parentheses there. And then, so I'm going to multiply the irrational stuff first. X minus 7 plus square root 5 times x minus 7 minus square root 5. That's what I get when I distribute my negative. And I get negative square root 25, which is just 5. So I get negative 5. And I get positive 7 square root 5, and I get negative x square root 5. Now it's negative 7 times square root 5, so negative 7 square root 5. Negative 7 times negative 7 is going to be plus 49. I'm going to put it underneath the 5 because those are my like terms. Negative 7 times x is negative 7x, and x times square root 5 is positive x square root 5. X times negative 7, negative 7x, and x times x is x squared. So I end up, the radical terms cancel out. We get 44, negative 14x, plus 44x squared. Now I can multiply this together to get x squared minus 5x, and then I'll multiply my final answer by x squared minus 5x here. We'll move this up to get some space. I have negative 220x. I have positive 70x and negative 5x cubed. Sorry, this 70x squared. And x squared times 44 is 44x squared. And x squared times negative 14x is negative 14x cubed. And x squared times x squared is x to the 4th. So we have x to the 4th minus 19x cubed plus 114x squared minus 220x. Okay, the next set, find all the zeros, so that means even the imaginary ones we're going to find on this one. First one, again, I don't have any common factors with the 7 and the 10, so that's going to be a substitution. Let's start with 1. Let's see, 1, 4, negative 4, negative 7, negative 10. I have 1, 2, 5, and 10 as my options. So, and my coefficient's 1, so I don't have to worry about fractions. So 1, 1, 5, 5, 2, 2 doesn't work. Negative 1, 1, 4, negative 7, negative 10 are my coefficients. 1, negative 1, let's see, 3, negative 3, negative 10, and positive 10, 0. So I got a 0 of negative 1. I have x squared plus 3x minus 10, which does not factor because there are not two numbers that multiply. Oh, yes, the x minus 5 or plus 5 and x minus 2. Right, 5 minus 2 is positive 3, 5 times negative 2 is negative 10, so my x's are negative 5, positive 2, and the negative 1 that I had found earlier. G, number 17, g of x is an x to the 5th problem. So we've got quite a bit of looking to do here. We're looking for 5 answers. The sign change is 1. Oops. I didn't know I could erase that. So, hold on. Let's see. I have 1 sign change, no sign change, 2 sign change, 3 sign change, 4 sign changes. So 4 of my 5 answers are positive. Oh my goodness. I have 4 positives. 240, this is going to be a really large list. So we know we can probably start with 1, 2, 3, and 4. It's even divisible by 5. This is where you probably don't want to make the entire list. So let's start with 1 and negative. Well, let's start with 1 and 2 because we know there's 4 positives, so we're more likely to find some positives in here. So let's start 1. It's 1, negative 1. Negative 16, 34, negative 132, and 240. So 1, 1, 0, 0. Negative 16, negative 16. 34 minus 16 is 18. 18. We're not even getting close to these big numbers. So we have negative 114, and so we're definitely not 0. Let's try positive 2. And the reason I'm not trying negative 1 is because there's 4 positives, so hopefully I can find one quicker if I do it this way. On the test, we made sure the numbers don't get this large. 1, 2, 1, 2, negative 14. 14 times 2 is negative 28. 34 minus 28 is 6. 6 times 2 is 12. Negative 132 plus 12 is negative 120. Negative 240, and I get 0. Yay. One of my x's is 2. And now I'm going to use my new numbers here. I'm going to use these numbers. And I can eliminate anything that's not a factor of 120 so far. These all work, so I'm going to keep going down my list. Let's try 3 with my new numbers, because now we'll omit an x to the 4th. So let's try 3. 1, 1, negative 14, 6, negative 120. So 1, 3, 4, 12, negative 2, negative 6, 0, 0. That didn't work. Let's try 4. 1, 1, negative 14, 6, negative 120. 1, 4, 5, 20, 6, 24. That's 30. 30 times 4 is 120. It's 0. I found another one, positive 4. Now I have 4 terms. This is x cubed plus 5x squared plus 6x plus 30. this looks a lot like a problem I could possibly use factor by grouping on, so let's try it. X squared times x plus 5, factor out of 6 times x plus 5, and I get x squared plus 6, and factor out your x plus 5. So I have x equals -5, that's the other one, so I had x equals, what worked? 3 and 4 worked. No, 3 did not work, 2 worked. 2 and 4, -5, and x squared plus 6 equals 0, x equals squared equals -6, x equals plus or minus I square root 6, and it said find all the zeros, so I need to include my imaginary, and there's my 5 answers. Okay, let's see, what's the next problem? I'll clear off some of this stuff. Uh-oh, accidentally deleted the problems. Okay, we are at number 18. T cubed plus 18t squared plus 81t equals 0. I don't have a constant, so that tells me I should factor out a t. T squared plus 18t plus 81. Now I'm at a factoring minute problem. T plus 9, t plus 9, and so t equals 0. T plus 9 equals 0. So t is 0 and -9. I don't need to write the -9 twice. It is a double root, which would change how it graphed. It would bounce off that -9 as a root. But we're not graphing these right now. And then number 19, x cubed plus 10x squared plus 23x plus 14. Again, I don't have any common factors in those last two terms, and so that's not going to be factored by grouping. 19. We have x cubed, so we have 1, 2, 7, and 14. Coefficient is 1, and there's no sign changes. So here's where we're going to say there's no sign changes, so there's no positives. So we're going to try only the negative numbers. That's going to save you time. -1, 1, 10, 23, 14. So 1, -1, 9, -9. 13 minus 9 is 14. -14, 0. It worked. Then I have x squared plus 9x plus 14. That factors to x plus 7, x plus 2. So x is -7, -2, and the one we got from our guess and check, -1. Okay, I'm going to stop the video here. You can find the rest of the problems in the second video.